Okay, so today we are going to finish up our probability unit. We're going to talk about conditional probability, two-way tables, and we're also going to talk about frequencies. So if you look at conditional probability, you're going to be given events A and B. And given these events, the conditional probability is the probability of event B occurring, knowing that event A has already occurred. Okay, so we've got a notation. We have P parenthesis B slash A. Okay, so we can read this as the probability of B given A. We have a formula that goes along with this. So this probability of B given A, it's a fraction. Up top, you're going to have the probability of A occurring. You're going to multiply that by the probability of B occurring. And you're going to divide this by the probability of A. Now, I know it seems silly because these two will cancel out, but we want to write it in this manner just because that's the way the formula is. So let's look at some examples. We've got to figure out what our event A is, and we've got to figure out what our event B is. And it's going to be kind of read backwards to you. It's going to ask you what the probability of B is, and it's going to give you A, okay? So on number 1 it says, Mitchell drew a card from a standard deck of playing cards. What's the probability that he drew a queen given that the card was red? So it's telling you the probability of B given A. So queen is B given A, which is red. So we're going to first figure out our probability of drawing a red card out of a standard deck of cards. So you've got 52 cards in a standard deck of cards. You know, you have an equal amount of red cards as you have black. So you have 26 red cards. So that's the probability of event A. That's going to go here, and it's going to go in the bottom. And now we've got to figure out the probability of event B happening. So we're drawing a queen out of this deck of cards. So you still have 52 cards. So let's think about how many queens we have in a deck of cards. Should have one of each suit, so you should have 4. So if you cancel these out, because they'll cancel, and reduce 4 over 52, you get 1 over 13. And that's your answer. Okay, so let's move on to example 2. A number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it is an odd number? So we have event A and event B. So perfect square is event B. Okay. Event A is that it's an odd number. Probability of B given A. So we want to first focus on event A happening. So odd numbers, from 1 to 100 we have a total 100 numbers. And odd numbers, there's an equal amount of odd as there are even, so you have 50 odd numbers. That goes down bottom as well. Now event B. So we have to figure out how many perfect squares there are from 1 to 100. So let's think about it. You have 1, you have 4, you have 9, you have 16, you have 25, you have 36, you have 49, you have 64, you have 81, and you have 100. So you have 10 perfect squares. So 10 out of 100 numbers there. If you cancel these, you end up with 1 over 10 after you reduce. Okay, let's look at number 3. There are 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take spinning class. So let's draw a Venn diagram here. This is going to help us figure this problem out. Okay, so I'm going to say this one's yoga and this one's spinning. And I know 62 people are in the yoga circle, but I don't know how many are in the middle yet. I know 48 total people are in the spinning, but I don't know how many in the middle, so I'm not going to write anything yet. But I also know 15 people that take yoga also take spinning. So 15 are in the middle. Okay, so if I take the 16 people, or 62, I'm sorry, if I take the 62 people total in yoga and take away 15, that'll leave me with what is just in this part of the circle. So 62 minus 15 is 47. And I'm going to do the same thing over here. I know there's 48 total people in this spinning circle, but I want to take out these 15 to get what's just over here on this side. So 48 minus 15 is 33. Okay. All right, now let's get back to the question. So it says, if a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take spinning. So let's figure out probability of A, probability of B. So you know yoga class is going to be your event B given they're in spinning. Okay. So we know they're in this spinning circle. We're going to work this one a little bit different than we worked the top two. Just a little bit simpler. We know that they're in spinning class. So total number of people in spinning class is 48. Okay. And what's the probability that they are also in yoga? Well, there's only 15 of them that are in yoga that are in spinning. So 15 is going to go up top. We're going to reduce this to 5 over 16. All we did here, different than this, is we cut out this common term here. We didn't write that in this problem. And that's what I'm going to do on number 4 as well. Okay, of the 30 students in Mrs. Smith's math class, 13 are athletes and 9 are in band. And 3 of the athletes are also in band. If one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. So again, Venn diagram helps quite a bit. I have athlete, I have band. Tells me 3 athletes are also in band, so 3 is the common number. It says 13 are athletes, so in just this circle, 13 minus 3, that's going to be 10. 9 are in band, so 9 minus 3, that's going to be 6. But we have 30 total students here. So if we think about this, 10 plus 3 plus 6, that's 19 students right there. So I know that I've got some other students that are not in athletics or band. So if there's 19 here, there's 11 other students that are not included in these circles. All right, so let's look at our question here. Okay, so it says if one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. So non-athletes. We don't want to look at any of the athletes. So total non-athletes right here are 6 and 11 put together. That's going to be 17 total non-athletes. And the probability that they're in band, well, we've got 6 people that are just in band here. So there's no reducing necessary. You can't reduce that, so that's your answer. Okay, we're going to look at two-way tables. Two-way tables are a table that records data that pertains to two different categories. So in the example it says, the table shows the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find each probability. So it says to find the probability that the student selected prefers football given that they're a girl. So we've got to look at the girl column here. So we've got to get the total number of girls here. So the total number of girls, if we add 6 plus 16, I get 22 total girls. Okay? Because I'm going to focus on my girl column first. So I've got 22 total girls. And then now I've got to figure out how many of those girls prefer football. So if you look at the column of girls that prefer football, there's 6 girls. So if I reduce that, I get 3 over 11. And that's my answer. Okay, now I'm going to work with this one. This is going to give me my denominator. So I've got to get the total number of people that prefer hockey. So if I look at the total number that prefer hockey here, 10 plus 16 is 26. And now given that they're a boy here, well, I've got 10 boys that prefer hockey. So if I reduce that, I get 5 over 13. So your second word, you've got to figure out the total number in that column or in that row depending on what it is. That'll be the denominator of your fraction. And then still looking at that same column or that same row, you got to move on to the next category, the first one. That'll give you your numerator, and then you reduce. Okay, so let's look at a few more like that. Flip it over. Okay, so on number 5, it says the table shows the results of a poll of 150 randomly selected middle school students who were asked if they take French or Spanish. So it says a 7th grader who takes French. So we've got to first focus on, let's see here, it tells me 7th grader who takes French. So there's no bar here like there has been. So our denominator is going to be just the total number of people in this poll, which is 150 students. So we're now going to look at the numerator as a 7th grader who takes French. So 7th grader who takes French, that's 25 students, and then reduce 1 over 6. So if it doesn't give you a bar anywhere in there, the total number is going to be the total number of people that were surveyed. Okay? All right. So now on part B it says an 8th grader given that they take Spanish. So let's look at the Spanish. We've got to add all of these up. If we add up 23, 12, and 33, my total is 68. So that's my denominator. Now out of that column I have 33 that are 8th graders. So 33 goes up top. Let's see if this reduces. Remember that you can type it into your calculator math enter, but it doesn't reduce, so that's your answer. Okay, moving on. We got to figure out how many 6th graders we have here. 19 plus 23 gives me 42. And then out of those 6th graders, I know that I have 19 that take French. That doesn't reduce. Okay, and last one. Takes French. We got to add up how many take French. 19, 25, and 38 is 82 students. 7th graders that take French, that makes up 25 of them, and that doesn't reduce. Okay, so let's look at number 6. So it says the table shows the results of a poll of randomly selected juniors and seniors who were asked if they attended prom. So So it says a junior that did not attend prom. So if they did not attend prom, we've got to see how many didn't attend. So it doesn't have a bar again. So our total number is going to be the total number of people that were involved in this poll. So we've got to add up everybody. 28, 97, 56, and 19. That makes up 200 people involved in the poll. And then the junior that didn't attend prom, that was 56 of them. So if I reduce that, 7 over 25. Okay, total number of seniors, 97 plus 19 makes up 116. And did not attend prom, the no's were 19 of them, and it doesn't reduce. Okay, attended prom, the yeses, 28 plus 97 is 125. And out of those yeses, there were 28 juniors. That doesn't reduce either. Okay, so the last bit that we're going to talk about are frequencies. So you have joint relative frequencies, and then you have marginal relative frequencies. So it says for joint relative frequencies, it's the values in each category divided by total number of values. And then marginal is found by totaling each row in each column. Okay, so this one's a little bit different than what we've been doing. So it says the table below shows the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, or no bags. Find the joint relative and marginal relative frequencies, then find each probability. So if you look here, we have 16 first class passengers that checked 2 bags, 52 coach class that checked 2 bags, 12 first class that checked 1, 60 coach class that checked 1, and so on. So before I ever begin, I want to get my total number of people that were polled here. So if I add all those up, 16, 52, 12, 60, 2, and 18, I get 160 total passengers. So I'm going to first focus on finding this. So let's see here. It says we've got to find the first class that checked 2 bags, and we want to get that probability here. And we're going to write these as decimals. So what you're going to do is you're going to take this little box here, the first class that checked 2 bags, this number, and we're going to divide it by the total number of passengers. So we're going to take 16 and we're going to divide it by 160. And you end up with 0.1. Okay. So that's what we're going to do here as well. We're going to take our total number here, or not our total number, but we're going to take our number of first class passengers that checked 1 bag, and we're dividing it by the total. So I'm going to take 12 and I'm going to divide it by 160 for this one. That's all we're doing. So I'm going to kind of try to write that in the top so that you know what I'm doing here in my calculator. We took 16 and we divided by 160. Here we're going to take 12 and we're going to divide it by 160. If you do that, you get 0.075. Don't round or anything, leave it as it is. And then we're going to take this number, we're going to take 2 divided by 160. And you're going to end up with 0.0125. So if we take the total, we're just adding these up. 0.1 plus 0.075 plus 0.0125. If we add all of those up, you get 0.1875. Okay. My coach class, we're doing the same thing. 52 divided by 160. If you do that in your calculator, you get 0.325. Here again, you're going to take 60 divided by 160. You get 0.375. Here again, you're going to take 18 divided by 160. You get 0.1125. And then total, you're going to add those up, 0.325 plus 0.375 plus 0.1125. You get 0.8125 when you add. Okay, so now the totals here, we're going to add them row by row instead of column by column. So we're adding 0.1 plus 0.325. And you get 0.425. Here, 0.075 plus 0.375, you get 0.45. And here, if you add these up, you get 0.125. So if you add them now to get this total down here, you get 1. 0.425 plus 0.45 plus 0.125. So we got a few questions to answer, and then we're done. Okay, so on A, it says the probability of a coach class passenger that did not check any bags. So we're going to look at our table. So we're looking for a coach class passenger that didn't check any bags. So coach class, no bags, that's right here. So it's 0.1125. We're going to get the percentage. So in other words, we're going to convert this to a percentage by moving the decimal over 2 spaces. You remember that? You take 11.25%. Okay. So on this one it says a first class passenger that checked at least 1 bag. So first class passenger that checked at least 1 bag. This one checked at least 1 bag, but so did this one. So we're going to add these two together. We're going to put 0.075 together with 0.1. So you get 0.175. So you want to switch it to a percentage. So it changes to 17.5%. So you can see where this data would make a difference to these airline companies when they're going to charge you for extra baggage. They want to see how many people are bringing baggage on. They want to look at the data and see if it would be profitable for them to charge extra. Okay, let's look at C. Okay, a coach class passenger, given that he checked 1 bag. So we want to look at the total of checking 1 bag. So the total of checking 1 bag, that total is 0.45. Okay. Okay, so looking at checking 1 bag, looking at if they were coach class, that would be 0.375. So if I divide those, I get 0.83 repeating. If I move my decimal over to get a percentage, I get 83.3%. Okay, last one. So my first class total was 0.1875. Checking 2 bags in that column was 0.1. If I divide, I get 0.53 repeating. So I'm going to change that to a percentage, and I get 53.3%. Alright. Okay, so that's it for this lesson. There is a homework that I want you to get started on. So I want you to work on this until the bell rings. Everybody needs to be quietly working on this paper.